Hey PSTATS, this is Mrs. Harding. This video is for activity 9.2b. In your previous activity, you talked about doing a one-tailed test. You covered a basketball player and the potato problem. Today what we're going to take a look at is how to perform a two-tailed test and then how a confidence interval compares when drawing conclusions about a two-tailed test. So in this first example that's here, it says, according to the Center for Disease Control and Prevention, 50% of high school students have never smoked a cigarette. James wonders whether this national result holds true in his large urban high school. All right, so some important ideas in there. It says he's just wondering if it's any different for his high school. He doesn't have any speculation about whether it's more or less at his particular high school. So this is a case where we're going to be looking at extreme values on both ends of the sampling distribution. So when you're stating the null and alternate hypothesis, the null hypothesis would be that nothing is different about his high school. So the proportion is still 0.5. His alternate hypothesis then is just that the proportion is not equal to 0.5. Something other than 50% applies to his high school. Taking a look at the conditions that are met, a simple random sample has been stated. They did make a point of saying it was a large high school, so it's likely that his sample of 150 is less than 10% of the population of kids at the high school. For the large counts condition, noted here that we are using the proportion from the null hypothesis. So if the null hypothesis is true, which is the basis of our sampling distribution, NP and N times 1 minus P are both greater than or equal to 10. We can use a normal distribution, and the standard error for the sampling distribution is 0.0408. So the conditions here have all been met. We've set up the values for the sampling distribution. But I want you to take a look at this. He had a certain sample proportion from his high school that was 0.6. When you're looking at a two-tailed or two-sided hypothesis test, you are considering the likelihood of getting a sample that's given that is as extreme as that sample in both directions. So 0.6, his sample is here. So we're looking at the area to the right of 0.6, but we're also concerned with whether it is that same distance in the other direction. So we're also considering 0.4 and below. So the probability of getting a sample statistic less than or equal to 0.4 or greater than or equal to 0.6, given that the true proportion is 0.5. Now you should realize that these two areas are the same. This is symmetric. So really you just need to find one area and double it. So I'm going to double the probability of getting a z greater than or equal to 2.45. So we end up here with the probability of getting a sample like his or more extreme of being 0.0143. This is the p-value of this test. The p-value is 0.0143. Now we're talking about an alpha level of 0.05. So the conclusion that we can make about this test, p-value is less than alpha, so we can reject the null hypothesis. There is evidence that p is not equal to 0.5 and that it is something other than 50% of students at James's high school that have never smoked. Now you don't want to make any assumptions on this based on the fact that his particular sample was greater than 50%. All this test shows is that it's likely something other than 50%. Another thing that you can take a look at when you're doing a two-sided hypothesis test is you can compare it to the confidence interval that would have been created from the sample. Now you can't do this for a one-sided hypothesis test. You can only do this for a two-sided hypothesis test. So if we're doing a two-sided hypothesis test at an alpha level of 0.05, this corresponds to a 95% confidence interval. So what we're going to do is we're going to construct a confidence interval for the true proportion of students at his high school who have smoked cigarettes. We're going to take a look at the conditions. It says the randomization and independence conditions for constructing the interval are the same, and we've already checked those, so we don't need to worry about it. What you want to think about here for the normality condition is we're constructing a confidence interval. There is no null hypothesis that we're basing our results on. So you're not going to use 0.5 as the proportion. You're going to take a look at the sample proportion. You're going to use p hat. So to verify the normality condition, you're going to look at expected successes and failures based on the proportion that he found for his high school. And you can see it there on the screen. Both are at least 10. So that makes all of the condition. So in addition to checking the large counts condition using p hat as opposed to the 50%, we also have to make sure that we're using p hat when we determine the standard error for the sampling distribution. So we're going to go ahead and create this confidence interval. And you can see here point estimate, critical value, and then standard error using p hat equals 0.6 to construct this interval from 0.52 to 0.68. So if all we had done from the very beginning was to take his sample and create a confidence interval, this is the confidence interval it would have created. And how we would have interpreted it, I'm 95% confident that this interval contains the population proportion. Now, if you compare this to our test, 0.5 is not in this interval. So this interval also gives us evidence that the proportion of students at his high school who have smoked cigarettes is not 50%. It is something other than 50%. Everything in that interval is above 50. So this is consistent with our significance test. So if you flip to the next page, there is a sample problem, check your understanding. I'd like you to go ahead and pause the video, give this a try, check your answer with the answers that are in your OneNote notebook. Okay, if you had any questions about that, check your understanding, please take note of it and ask either me or Mr. Bowman when you're in class. If you go to the next page, it shows you in here some computer output. So sometimes the significance test is conducted for you and the results are printed in computer output. The scenario shown below, what proportion of students are willing to report cheating by other students? The student project put this question to an SRS of 172 undergraduates at a large university. You witnessed 2 students cheating on a quiz. Do you go to the professor? The Minitab output below shows the results of the significance test and a 95% confidence interval based on the survey data. So what can you pull from this computer output? At the top it says test of p equals 0.15. So they're testing whether or not it is 15% versus not 15%. So part A defined the parameter. The parameter is the proportion of students at a large university that would report cheating. The null hypothesis given to you there, that the proportion is 15, versus the alternate hypothesis that it's not 15. Interpret the p-value. Well, let's look through the rest of this. There's a sample where 19 people out of 172 said that they would report it. This is the 95% confidence interval. This is the z-value, and this is the p-value. So when you're interpreting the p-value, this is if the true proportion of students that would report cheating is 0.15, then the chance of getting a sample proportion as far or further away from 0.5 as what we did is 0.146. This is the chance that we would get a sample as extreme as 19 out of 172. So then in part D, do these data provide convincing evidence at the 0.05 level of significance that the actual population proportion differs from 0.15? So this is not convincing evidence. The p-value is larger than alpha. 0.146 is larger than 0.05. So we do not have convincing evidence that the proportion of students at a large university that would report cheating on a quiz is not 0.15. We would fail to reject the null hypothesis. If you scroll to the next page then, it says explain how the confidence interval supports the same conclusion. Well, let's go back and look at that. Oops, if I can scroll here. at what the confidence interval was. The confidence interval given is here. Take note of the fact that 0.15 is in this confidence interval. So because the 95% confidence interval does still contain 0.15, it suggests that 0.15 is a plausible value. So we cannot reject the null hypothesis based on that confidence interval. And again, remember, confidence intervals can only be used alongside of a two-tailed hypothesis test. A one-tailed hypothesis test can be connected with a one-sided significance test can be mirrored in a confidence interval, but the steps for it are a little bit more complicated. So for our purposes, we're just looking at two-sided hypothesis testing as compared to a confidence interval. At the very end of this, there's another check your understanding. So I'd like you to pause your video, give the check your understanding a try, check the answers in the OneNote notebook. If you have any questions regarding either of the checks for understanding in this or any of the examples or explanations, please let me or Mr. Bowman know in class.